Okay, so I'm going to be doing number 3. Consider the curve given by x squared plus 4y squared equals 7 plus 3xy. And A asks us to show that dy over dx equals 3y minus 2x 8y minus 3x. So the first step is to take the derivative of this function, or this curve. So first we're going to do 2x dx over dx. Then we multiply the power to 4, so 8y dy over dx equals, so we have 7, it's a constant, so it's a 0, and so 3xy, we take the product rule, and the answer will be, so this is separate, and the answer for that will be 3y plus 3x dy over dx. This is dy. Okay. So now we simplify, so it's basically 2x, because this is disappear, and plus 8y dy over dx equals 3y plus 3x dy over dx. I'm going to bring a new page, and we can copy that again, just for reference. So we're trying to solve for dy over dx, so we subtract 2x, and we also subtract 3x over dy dx. So that will be 8y minus 3x dy over dx equals 3y minus 2x. So the final step is we divide 8y minus 3x, and that will bring us to our final answer for what we were trying to show, which is this. For the product rule, for this one, if you guys don't remember, the product rule is f of x g plus g prime of x. And once you do that, you will get 3y plus 3x dy over dx from Yeah, basically. That's part A.
Now we set the problem to 0, so 3y minus 2x over 8y minus 3x equals 0. Then now we plug in 3 for x. So 2, substitute 3 for x over 8y minus 3 times 3 equals 0. Okay, now it's 3y minus 6 over 8y minus 9 equals 0. Then we multiply 8y minus 9 to both sides. So that cancels. So it's 3y minus 6 equals 0.
Okay, so now we're going to solve for y. So we're going to add 6 to each side. Get 3y equals 6. And then divide by 3. And you get y equals 2. Okay, so for B, they gave us the x-coordinate was 3. And we just solved right now for y, which equals 2. So the point would be 3, 2. To prove that there is a point on the curve, we plug in 3, 2 into the original equation, which is 3y. Oh, I was just kidding about the last part. The original equation is x squared plus 4y to the second, which equals 7 plus 3xy. Okay, so we're plugging x, so 3 squared plus 4, 2 squared equals 7 plus 3, 3, 2. Let's put 2 here. Okay, so then it would be 9 plus 8. No, 8 times 2 equals 25 on this side. And then this would be 25, so 25, since they're both, it proves that is right. Okay, so here's the reason. Okay, so this wasn't right here. It was actually 4 times 4, and then you get the 25 plus 25.
Okay, so for part C, we're going to do the quotient rule. Okay, so the quotient rule is f prime of x multiplied by g of x minus f of x g prime of x, all divided by g of x squared. So next, we're going to use the quotient rule for the slope. That's dy over dx equals 3y minus 2x over 8y minus 3x. This is the first derivative. This part is f of x, and the denominator is To recall, this is the slope. dy over dx equals 3y minus 2x over 8x minus, 8y minus 3x. Now using the quotient rule, f prime of x is going to be 3 dy over dx minus 2, and then we're going to multiply that by g of x, which is 8y minus 3x. And then we're going to subtract f of x, which is 3y minus 2x, multiplied by g prime of x. Dy over dx minus 3. And then everything is divided by g of x squared, which is 8y minus 3x squared. So next we are going to plug in the point that we found earlier in the problem, which was 3, 2. So we're going to plug this point into the second derivative that we found earlier using the quotient rule. So once we plug in this point, we get 8 times 2 minus 3 times 3 multiplied by negative 2 minus 3 times 2 minus 2 times 3 times negative 3.
I had to think about it for a second. Like, what am I going to do?
Divided by 8 times 2 minus 3 times 3 squared. Alright, so now looking at this part, 3 times 2 is 6, and then negative 2 times 3 is negative 6. So 6 minus 6 is 0. And 0 times negative 3 is also 0. So this part of the second derivative will cancel out. So now, when you plug this part into your calculator, you would get negative 14 over 49. And this simplifies to negative 2 over 7.
We forgot to mention that when you take the quotient rule, dy over dx equals 0 because we're finding the second derivative, and so when you find that dy over dx is 0, and when you plug that in, it will be easier for you to plug the quotient.
We're going to plug it into your calculator to find the x's.